Mobile robots are increasingly used in everyday life to autonomously realize missions such as exploring rooms, delivering goods, or following certain paths of surveillance. The current robotic market is asking for a radical shift in the development of robotic applications where mission specification is performed by robotic users that are not highly qualified and specialized in robotics. To this aim, we propose Promise, a domain-specific language that supports users that do not necessarily have technical knowledge in mission specification. The DSL contains a set of atomic tasks that can be executed by robots and a set of operators that allow the composition of these tasks in complex missions. The current example shows how Promise allows the definition of a mission in a few minutes. As we show in the example, mission specification can be performed through a textual and a graphical interface. For instance, if an intruder is detected while the robot patrols, it must raise an alarm. If the robot runs out of battery, it must visit the charging station and perform the charging action. When the textual syntax is saved, an intermediate LTL-based language is automatically generated. It is a formal representation of the mission the robot should achieve. It is not intended to be read by humans since it is sent to each robot, where an interpreter parses it and applies the semantics of each operator. With Promise, we strive to propose a language that is powerful enough to define more complex missions like the one presented in the next example. In this mission, two robots simulate a restaurant management scenario. We first replicated the scenario via simulation using a Tiago robot. We then implemented it over a Turtlebot in the facilities of Chalmers and Gothenburg University. We use events to realize the evaluation. The mission starts with the robot waiting at iStart. The robot evaluates if the request came from table 1 or table 2. If the event holds, the interpreter then checks if the table is already being served by another robot and goes back to the initial position if it is the case. In this case, the help is requested from table 1, which is not being served by any robot, so the robot starts performing a sequence of tasks. Tasks represent simple activities whose execution can be delegated to the robots. For example, a task may require a robot to visit a set of locations or to perform an action. Actions are simulated in this experiment. We specify with events E2 and EF2 that clients from table 2 request the help from the robot when it is done with table 1. Once this behavior is finished, the robot returns to its per default mission, waiting at iStar for more clients to serve. The mission also specifies that the robot should go back to its initial position if it is requested by the user.